Hello, good evening all. Hello, can you hear me all? Hello, you can hear me?
Yes, sir.
Yes, sir.
Fine. So in the morning session, we started thin cylinder derivations, correct? Sorry, we completed the derivation. We started the numerical problem, right? Hello, could you respond please? Hello, could you respond?
Yes, sir.
Now we continue the problems on that. Let me see. You can see the screen. You can able to see the screen. Hello. 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 Can you able to see the screen?
Yes, sir.
Okay. We completed, I think, two problems, correct? Hello. Hello. Are you there? Hello.
Yes, sir.
We completed two problems, right? Hello. Can you hear me or not properly? Tell me first.
Yes, sir.
Then you should respond.
Yes, sir. We
Please
hear.
respond, all of you. Now we will continue the problem on that. So I think delta L problem. This is over. Uh, so same. See, this is the same problem. It thin cylinder 1 mm in dia, 1 meter in dia, 3 meter long, has metal thickness of 10 mm. It is subject to an internal fluid pressure of 3 megapascal. Determine the circumferential stress, longitudinal stress, circumferential longitudinal and volumetric strength. It is same type in the previous problem, only the data is changed. That you should check out. Okay. You have to do it. This one is a homework problem. What is done is covered in the morning. The same type, only the data is changed. That's all. Are you getting? Hello. Hello.
Yes, sir.
Now we'll take a fourth problem, the third problem. That means, so that is a cylinder shell having a dia of 750 mm. Dia of 750 mm. it has to be withstand a water head of 60 meter. Find the thickness of the pipe. If the permissible stress is 20 Newton per mm square, unit weight of the water is 9810 Newton per meter cube. That's all. See, this is the examination problem. They given one cylinder. They're saying that the cylinder shell is there. It is having diameter 750 mm, and it to withstand the head. What is head? Let you know. So head, let us call as that is H. So it can withstand the water head up to 60 meter. Find the thickness of the pipe. If the permissible stress is 20 Newton per mm square stresses, and unit weight of water is 9810 Newton per mm. So unit weight of water, that is nothing but weight density. Unit weight of water, it is nothing but weight density, that is 9810 Newton per mm square. You can take a screenshot of this problem, all of you. Taken?
Yes, sir.
Fine. Now we'll see how to solve this problem. It's a very small problem only, 4 marks problem. Now they given the data are, let me see, diameter is 1 meter, D is 1 meter dia, that is nothing but 1000 mm, and also they given the length, it is 3 meter, that is the sense 3000 mm. Now also they given fluid pressure and thickness is 10 mm, and also given the fluid pressure P, they given 3 megapascal. Megapascal to Newton per mm square means 1 megapascal equal to 1 Newton per mm square. So therefore we need to calculate, sorry, not this problem. Problem is different, sir. A cylindrical shell having diameter 750. Written other data, sorry. D is 750 mm, 750 mm. Now it has to withstand a water head, it in the sense H, 60 meter. 60 meter is there. Now find the thickness of the pipe. We need to calculate what is T thickness. Then if the permissible stress, now permissible stress they given, that is, let us call it, that is sigma 20 Newton per mm square. Now we need to and also they given unit weight of water. Unit weight of water is nothing but weight density, that is 9810 Newton per meter cube. How to get know this is weight density means by seeing the unit. See, there are two types of density as we know. One is called mass density, that is mass per unit volume. One is called weight density, that is weight per unit volume. So always mass per unit volume unit is kg per meter cube or mm cube. This one is Newton per mm cube, weight density. So based on this unit of weight density, it is in the weight density. The given is weight density, that is rho W is W by V. Now we need to calculate the thickness. Are you able to see now board now?
Yes, sir.
Now the given permissible stress is 20 Newton per mm square. That means we having stresses are two equation. One is circumferential stress, another one is sigma L, sigma C and sigma L. Now they are not mentioned which is this sigma, whether it is sigma C or sigma L. Which one I should consider? They saying permissible stresses. the permissible stresses. Now, which one I should consider, whether sigma C or sigma L? Can anyone?
Sigma C, sir.
Why sigma C? Why sigma C? Why sigma C?
Sir, because based on sigma C only we design cylinders.
Good, good. So, exactly right. Minute. In YouTube, whether it is coming ulta or not. Coming correctly? YouTube? Might become, I think, it is coming reverse now. YouTube? Hello? Hello?
Sir,
It's coming reverse in the YouTube, right? Hello? Check out in YouTube. Whether it's coming correct or not, YouTube check out.
sir, checking.
Huh? Now okay, now it will come correct. Now, someone said, good. We are going to design the thin cylinder based on the sigma C always. Why? Because sigma C always greater than the sigma L will be there. That is 2 times of sigma L will be there. Therefore, when you are going to consider that maximum stress, it is given, permissive stress means it is based on sigma C, not on sigma L. Therefore, this we can consider as sigma C. That is the best or safest design to consider that. Okay? Understood? Understood?
Yes, sir.
Now we know P sigma C is PD by 2T. So now I require T means I need P. So P is not given, but what they given is instead of that P, they given head and they given weight density. Therefore, P is rho W into how much head is there. Head in the head, what is this P, what is this head and all, it is comes in actually in a fluid mechanics topics in the next semester. Now for a time sake we don't want those things, so let's remember like this: pressure is rho W into H. So if you multiply these two, you'll get the this value. So that is 9810 into H value is 60. So if you do this, how much P value will be there? How much P value will be there? How much P?
588600.
5?
88.
In terms of scientific, you tell me. In terms of 10 raised to something.
Sir, 588.6 into 10 power 3.
588.6 into 10 power
3.
3. You will get in Newton per meter square. Why Newton per meter square means this is in Newton per meter cube into meter will give Newton per meter square. But I need to substitute in terms of Newton per mm square. How to convert Newton per meter square to Newton per mm square? 5.588.6 into 10 raised to 3 divided by meter to mm. 1 meter equal to how many mm?
1000.
1000 whole square. Why whole square? Because meter square is there. Therefore, what is the value you get? What is get? How much you will get in terms of Newton per mm square? You should memorize this. How much you'll get?
0.588.
0.588 Newton per mm square. So now we got P, therefore I can calculate T now easily. That is PD by 2T. Therefore T become PD by sigma C into 2. So therefore, how much T you will get? Check out in terms of mm. That's all the problem. How much? Tell me quickly.
11.02.
Yes, 11.02 mm will be there. Usually for design, we are not going to take like 11.02. We are going to round up to the next. That is, next number is 12. Should not go for lesser, because for this stress, this to withstand this pressure, this should be the thickness of my cylinder. If you take a lesser this, definitely it is going to fail. Therefore, always should be in higher number, then it will be in a safer side. Therefore, next round of number is 12 mm. You can go it. Understood?
Yes, sir.
All of you. All of you understood?
Yes, sir.
Keertana, Mani, you are not taking it, right?
Yes, sir.
No only you came. From 3 days you are not came. Okay, anyway, you informed me. Fine. So you go through the YouTube videos. Okay. Yesterday and
Okay,
today,
sir.
what we covered. New module we are doing. So please take a screenshot of this, all of you. Take a screenshot of this. And we'll move to the next. That is the last problem on this thin cylinder topic. Please take a screenshot. Taken?
Yes, sir.
Okay.
Fine. Now, let's see last problem on this topic. See, I have given some unit conversions. Suppose it may chances to give the pressure in terms of these units. Either it may be a bar. So usually bar also it is a unit of pressure. If you want to convert bar into meter per mm square means you should multiply by 0.1. Suppose if they given PSI. PSI means pounds per square inch. That is a British unit. So that if you want to convert into meter per mm square means multiply by 00689. Suppose it may given meter of water. Then you should multiply by 9.0098 meter per mm square. Suppose they are given in terms of kg per centimeter square pressure, then you should multiply by 98.06 newtons per mm square. Suppose they are given 1 mm Hg, these are the various units of pressure. In terms of mm of Hg they are given, then multiply by 0.000133 meter per mm square. Please take a screenshot of this. This is also very important. Sometimes they may given in the problem various units of pressure. To make it, you have to convert by multiply these factors. Should be known. Taken?
Yes, sir.
Fine. We go to the last problem on this topic, that is thin cylinder topic. Take a screenshot of this. Minute. One minute, don't take. You see one question paper, that is not. You see, in question paper, what are the questions on thin cylinder, not thick cylinder, thin cylinder, any problem is there, that we'll check out. The model number 2. Yeah. Given here, you can see in this they given a thin cylindrical shell with following dimension filled with a liquid at atmospheric pressure, length of 1.2 meter and external diameter 200 mm. The thickness of the metal is 8 mm. Find the value of pressure exerted by the liquid on the walls of the cylinder and would stress induced if an additional volume of 25,000 mm³ of liquid is pumped into the cylinder. E is equal to 2.1 into 10 raised to 5 Newton per mm square and mu is 0.33. So this is problem in morning we solved. Hope you can remember. This is delta we taken and we solved P. Correct no? Hello? Bhaskar.
Yes, sir. Sir, mu means
Mu in the sense the 1 by m. That is so yeah. So either there some textbook they will use 1 by m. Some textbook author they will use mu. So mu in the sense it is nothing but Poisson's ratio. Okay?
yes, sir.
So that means you should take this as 1 by m. Now let me see in this. Yeah. A thin cylindrical shell is 1.2 meter in diameter and 3 meter long as a metal wall thickness of 12 mm. It is subject to internal pressure of 3.2 mm. Find the circumferential and longitudinal strain. Also determine change in volume of the bar. This also same problem we solved in the morning 6 marks. But take mu as 0.3. Mu in the sense 1 by m. Keep this in mind. Same problem only is solved. Okay? 6 marks. Got it?
Yes, sir.
And derive the expression for wood stress and longitudinal stress of thin cylinder subject to internal fluid pressure. That is 6 marks. Wood stress derivation and longitudinal stress derivation. Next. So derive the circumferential longitudinal stress. 10 marks derivation. A pipe of this is thick cylinder problem. Okay, that is not there. So we are not next is going to cover that is one. Only we are looking for thin cylinder. This also thick cylinder problem. Okay, stress circumferential stress and longitudinal stress derivation 8 marks. In next question paper also. Second question is okay, model number 2. Model number 2. Okay. Thick cylinder problem that is also. Model number 2. Okay. Model 2. Then. So thick cylinder problem is very important than the thin cylinder. Most of the time they ask you the derivation only in thin cylinder topic. That is the circumferential and longitudinal stress. So and differentiate thin and thick cylinder. That is thick cylinder we are going to discuss in the next topic. And thick cylinder problem. Okay, fine. So we'll see how this problem is going to take place. So that is enough now. Okay, that's problem is enough to solve the thin cylinder problem. That what we solved that is enough. We'll stop it there. Okay.
Yes, sir.
So that is enough now. So we'll take the thick cylinder topic, and that is very important derivation in that also. Especially compared to derivation problems is very important. That will give definitely it will come in exam. You see in the question paper, no thick cylinder problem definitely it will come in exam. So we'll see that how those problems are going to solve. I will check out any other problems left in the thin cylinder. Right. So we'll take a thick cylinder now. Can you hear me all? Can you hear me right?
Yes, sir.
Kirtana?
Yes, sir.
Thick cylinder. So what is thick cylinder means? What may be the ratio? What may be the ratio of thick cylinder should be there? How much? Hello? How much ratio? Thickness to this ratio, how much should be there?
Greater than 1/10.
Greater than
1/10.
1/10. That is very important. Greater than 1/10 should be there. So if thickness to internal diameter is greater than 1/10, then it is called thick cylinder. So thick cylinder always having more thickness should be there to withstand the high pressure. Example like boiler, shell, it may be this one what you call gun barrels. So engine cylinder, that is also a kind of cylinder, it is also kind of thick cylinder only. So to withstand wear and high pressure, they are going to use thick cylinder. So then if you want to design the thick cylinder, then you should refer this concept. That is very, very important. So here, so mainly thing is in the thick cylinder, the stresses in all direction. So same thing. Here also stresses what is developed. This is what is going to develop in same thing, circumferential stress, longitudinal stress, as well as radial stresses. So these radial stresses we neglected in the case of thin cylinder, but in case of thick cylinder, you should not be going to be neglect because thickness is more. Therefore, radial stress having also should be having some dominant. It's having some magnitude should be there. So you can't able to neglect that. That is the one very important thing concept. And here in thick cylinder, usually sigma c will be not uniform. Will not be uniform. Whereas in case of thin cylinder, it is uniform will be there. So here, usually, suppose you take a cylinder like this, inner diameter and outer diameter, it is having a thickness like this. So usually this sigma c for inner cylinder, inner radius, inner surface, it is maximum will be there. Sigma c will be maximum at here and minimum at outer surface will be there. So this is one more very important difference. So sigma c will be always maximum at inner surface, inner radius, and outer radius it is usually minimum will be there. It is not zero, minimum will be there. So therefore, this is the main difference between the thin and thin cylinder. So I can write the difference first. What may be the difference? Shall we proceed to the difference first? That is also they will ask for one more time 2 or 3 marks. Then we'll take up this. Hello? Can you hear me?
Yes, sir.
So thin cylinder and thick cylinder, what is the difference? First difference I can write. Thin cylinder, thick cylinder, what is the difference?
It will be uniform, but it is not uniform.
The main difference is here T by Di is less than 1 by 10, here more than 1 by 10. That is one difference. And sigma C is uniform in the thin cylinder. Here it is not uniform. It is not uniform. Maximum at inner surface, minimum at outer surface. And what may be the other difference you can say? What may be the other difference? So here radial thickness, radial stress is negligible. Here radial stress is considerable. Can you tell me any other difference? Still any other difference? So it may be it's to withstand low pressure, but thick cylinder withstand high pressure. So that's all the difference I can say. Hello, can you hear me?
Yes, sir.
So that's all the difference. In one examination they asked it for 4 marks. Then you should write the table like this and this one. Now we'll move to the thick part. Next in this is we are going to derive the equations now. So the main scientist to work on the thick cylinder topic is Lens. The name of the scientist is called Lens. So mainly this person, he worked on the thick cylinder, he derived his own expression. So therefore, when you are going to deal with design the thick cylinder, you should refer the Lens equations. So that Lens equation, what we are going to next, we are going to derive the things. It's very important one. So let me see what is the Lens equation will come. Can you hear me all right properly?
Sir, YouTube ಅಲ್ಲಿ ಸ್ಕ್ರೀನ್ ರಿವರ್ಸ್ ಐತಂತ. ಸರ್ ರಿವರ್ಸ್ ಐತೆ ಅಂತ ಟೆಕ್ಸ್ಟ್ ಮಾಡುವಾಗ.
ಇವಾಗಲೂ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಲ್ಲ? I can see here it is proper. Now you can check faster.
ಸರ್ ಇವಾಗೂ ರಿವರ್ಸ್ ಐತೆ.
Wait for some minute. Now you can see. Now see the text. Now also it's reverse.
So now it is correct.
Huh?
So correct ಆಗೈತಿ ಇವಾಗ.
Okay. So these are the main difference between thick and thin cylinder. You got now the difference, right?
Yes, sir.
Now next topic what we are discussing, that is very important with respect to the examination also. Mainly based on the Lens equation, problem is very important as well as derivation also. So therefore we are going to take up that derivation now. So that is Lens theory derivation. First, Lehm's theory. So Lehm's is the name of scientist. So he done the analysis on this six cylinder. He derived some his own expressions. That is what we are going to referring now. So before going to Lehm's theory or Lehm's equation, what we are before going to derive the Lehm's equation, there is some assumptions he also made. Without assumption, we can't deal with any analytical part. So the first assumption what he made, let me see. What will be the first common assumptions will be there? What is the first common
Material
assumption?
is
Everyone will made
isotropic
it.
and homogeneous.
Material is
Isotropic and homogeneous.
isotropic and it is homogeneous. So second assumption what they made is longitudinal strain it is uniform. Longitudinal strain it is uniform. So this is the main assumption he made by the Lehm's. That's why it's based on this assumption it's called Lehm's theory. So longitudinal strain is uniform across the section, across the cross section of the cylinder. That is the main important, very important assumption he made by the Lehm's. Plane section of the cylinder. Next assumption, plane section of the cylinder perpendicular to longitudinal axis. Perpendicular to longitudinal axis. Longitudinal axis remains plane under the pressure. So this is what the same assumption will made in the thin cylinder also. So when you are going to apply the pressure, there will be the planes are not the same. It will going to change its shape. But after they apply the pressure also, it remain plane only. That is what he made. The plane section of the cylinder perpendicular to the axis, longitudinal axis. See, this is the cylinder, and this is longitudinal axis. Longitudinal axis perpendicular means this one. Correct now? So this will be plane. That means exactly circular only will be there. It is exactly circular only will be there even after the apply the pressure. But basically it is not true. It is not true. It will be diameter will be not like the shape of the cylinder will not be circular. It may be take some deviation after apply the pressure. Understood?
Sir.
So these are some very important assumption. Must and should you have to write this. So based on this assumption, the theory based on this assumption is known as the theory based on above assumption known as Lehm's theory. The based on this assumption is known as Lehm's theory. Understood the assumptions? Must and should you have to write in the exam. Understood? Understood all of you?
Yes, sir.
Can take a screenshot of this. Now we'll start a derivation. Please concentrate on the derivation. It's very important. Derivation. Let me concentrate. It is may take 2 pages. 1, 2, yeah. But if you practice, it will be very easy only. First thing is you should understand the concept. I will repeat. Hope you can take on the screenshot of this. Now I'm going to rub this. So let me derive the Lehm's equation. So now for this, the figure is very important. The way of writing the figure is very important. So Lehm's equation, we are going to derive the Lehm's equation for thick cylinder now. This is very important derivation. So for this, we have to write the figure. So that figure is also very important. Are you getting? Now I'm taking cross section of the cylinder now. One is outer radius or diameter. You should use a compass to write in exam. This is inner radius. So here in inner radius there will be a pressure will be acting. There will be a pressure is acting like this in all direction internally. Is P, that is P. Now in outer also there will be a pressure is acting, that is radial pressures. Always pressure will be act towards the member or towards the surface inward. This is PR. That is called as PR. Now in order to derive the Lamb's equation, what Lamb's is did is, so this hello, can you hear me now? You can hear me?
Yes, sir.
Now what Lamb's is considered the inner radius, what is the pressure is acting, he considers Pi. Outer radius, what is the pressure is acting, it is not PR, it is P naught. So this is inner radius, this is Ri, this is outer radius R naught. Now what Lamb's did is, he consider one small cylindrical portion. He consider one minute. Hello. 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 ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹೇಳಿ. ಈ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ, ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸರಿ ಆಯ್ತು. I will write it still what figure. Hope it look like circular. I don't have compass. So this is the outer radius R naught. This is inner radius. Now the pressure is acting. The pressure is acting outside also in the outer radius. That pressure they called as P naught. Radially in all direction. Like this. This is P naught. Now what Lamb's did is, he taken one small elemental portion. He taken one small elemental portion ring like this. He taken one small elemental portion like this. Okay, this portion like this. So it is at a radius of x. This elemental portion at a radius of x, and it is having a thickness. Dx. It is having a thickness dx. Are you getting the figure right? First of all,
Yes.
hello. Are you getting the figure now?
Yes, sir.
Now I'm going to take one off portion on the side view. We cut this, how it will look, only off. I'm going to write here. Okay, I'm going to write the things. That is this elemental portion I'm going to write in here. So that also I will write it in red color. It's better because already written in the red color only. Okay, it's better to use. I will take the side view of this. Now I will show you here. So this is the same elemental ring. I cut it like this and I'm showing like this. So this is the center now. So this is the center. Now it is at the radius, ear to ear it is x. and here radius is x, and it is having a thickness. That thickness they consider as dx. So that thickness it is considered dx on both the side. Okay. Now it is pressure is acting. The pressure is acting on this direction also on the elemental ring. This is the elemental ring side view. So on elemental also inside it is pressure is acting. That inside pressure acting inner radius it is called P. It is called Px. It is called Px, and the some pressure which is acting outside also like this with for an elemental ring. I'm talking about this is elemental ring. Okay, that is called Px plus dx. So this is pressure is not dx, I think. Let me see what they consider dpx. Px plus dp suffix x. Are you getting?